Hi everyone, I'm Philip, Marketing Manager at 64 Audio. We're here at the headquarters of Vancouver, Washington to talk about measurements, earphone measurements, IEM measurements, headphone measurements. Typically we do educational content that is a lot wider reaching and for a wider audience to kind of give people an idea of what in-ear monitors are, how to use them, fairly basic stuff. This video is a little bit more on the expert level side. So this is something that will be useful for monitor engineers, monitor techs, tech directors at churches, folks that are dealing with other people's in-ear monitors and are responsible for other people's in-ear monitors. But of course, any of this information can be useful for you, whether you're using your own, whether you're curious about this sort of stuff. There's a lot of things that we won't be able to go into too much detail on just because you can have a whole course on the software or the microphones that we use. So we will gloss over a couple things. Feel free to give us grief in the comments about it. I'm sure there'll be some stuff up for debate. But yeah, this will just be kind of a good general overview of what it is, why we use it, and some tips and tricks to help you out in the field. So why do you need to measure in-ear monitors? It's not a necessity. You don't necessarily need to measure in-ear monitors, but it is useful for a few reasons. Mainly, you're able to diagnose issues with real data. So anyone who's worked with musicians or artists knows that there's a bit of a learning curve as far as what language you use and how to interpret the way that your artist will present an issue that they're having. And so again, you can teach a course in of itself on how to translate what an artist is saying to what the actual issue might be. So this is a way for you to be able to have data and something to actually refer to when there is a problem that's presented to you. And not only in the in-ear monitor, but it's also an easy way to diagnose problems in your signal chain. If you feel like there's some piece of equipment in your signal chain that is causing issues, you'll be able to diagnose that with a measurement system. So the basics of the setup, it's pretty much three parts other than the in-ear monitors. You have a microphone, an interface, and software. Of course, you've seen measurement systems out there, the little RTA microphones measuring speaker systems, big, large-scale PA systems in venues. And this is pretty much the same thing. The microphone is just a little bit of a different format, but it works the same way. This is the setup. This is really all you need. So the first thing you'll notice is that this microphone obviously looks different than your standard RTA microphones. They look like a little pencil when they're measuring a speaker. This is a great unit by Audix, the TM2. This is something that I've been using in the field for a couple of years when we go and visit artists and do demo sessions and things like that. I'm able to quickly test something to see if they're having any issues. Great product. They put this out a couple of years ago. I'd highly recommend checking it out. It does the job and you'll see kind of how you're able to use it. But the reason why it looks like this is these microphones are based on a microphone made by Gross, which is essentially the IEC 711 standard. If you want to learn more about that, there's tons of research and review videos and all this kind of stuff about the 711 coupler is what it's called. It's essentially an ear simulator. It's made to simulate what's happening in the ear so that when you're measuring it, the graph is coming up with something that's readable and discernible. You're able to see without many issues that you would see if you're just putting the in-ear monitors up against an RTA microphone. You'll learn later on that the accuracy of what you're seeing isn't necessarily as important as consistency when it comes to measuring in-ear monitors in the field in this way. Of course, if you're a reviewer of in-ear monitors and you need accuracy, this is what, a lot more important. But if you're out in the field measuring up against a reference trace, you're able to see issues with the IEMs. You don't necessarily need the accuracy, you just need consistency. So you have stuff like this. There's even companies that are making couplers for RTA microphones that'll allow you to measure in-ear monitors. All that stuff is probably great. And again, you'll see that it's more about consistency than accuracy. But there are major differences when it comes to these microphones and couplers And you'll also see that a little bit later in the video. We'll show you the difference between one versus another. So the 711 coupler is sort of ubiquitous in our industry, whether it's manufacturers, whether it's reviewers, even some of the major research that has been done, particularly by Harman in the early 2010s. They were using the 711 style ear simulator to do a lot of their research. So this is still virtually the standard from what we can tell. There's obviously other maybe new standards, like B&K has some of the large torso things that people are using nowadays, but we're still primarily using the 711 coupler in this building, and that's virtually what most of these are kind of made to emulate if you don't have like a genuine Gross microphone and power supply and all that. This is great because it doesn't require a power supply. It's just running off of phantom power from the interface, which is getting bus power from USB on the laptop. So you don't need an extra box like the other one that I'll show you. Interface-wise, just like any other transfer function measurement, it's okay if you don't understand what that means. We won't go too much detail on that. Basically just measurement. So just like any other measurement rig, you just need an interface that has multiple inputs and outputs. And you'll see why in a second when I kind of explain the transfer function measurement. But here I'm just using my Babyface Pro by RME. I personally like their stuff, and we like their stuff. We sell one of their DACs on our website, really great brand. And then measurement software. So I primarily use Smart. You'll see in the pro audio industry that most people are using Smart. So Smart is used all across the pro audio industry. We've noticed that it's not as prolific in the kind of audiophile space and music enthusiast space, but in pro audio, you know, everyone's seen Smart, everyone's used Smart. If you've been near a front of house console, you've seen the squiggly lines, as I like to call them. And that's not to say that this is the only software that you can use. There are certain free softwares. There are even more high-end testing measurement equipment like Audio Precision. You know, you're talking about getting into $50,000, $60,000 for a measurement system. With this, I believe it's a few $100s. There's multiple types of licenses that you can get. And personally, I would even recommend that people go and take the Smart class if you're ever able to. That will really go a long way to kind of explaining what all these lines mean. Whether you feel like you know that already or not, there's definitely a lot to learn from Smart. So transfer function measurement is basically you're measuring something with a microphone up against a reference tone. And in this case, we're gonna be using pink noise, but you can also use any sort of reference tone, you know, whether it's your mix coming out of your console or some sort of playback, some sort of music track. That's essentially it. The way we see what the sound is by putting it up against a flat signal. So you can see here, this cable, it's literally just looped right back into the interface. I'm sending pink noise through the output, and it's just going directly back into one of the inputs. That is set as my reference trace. And that's just, you know, a flat line of pink noise. That's one of the ways that you can sort of diagnose issues is depending on where you're setting your reference tone or where you're setting your reference information from, you're able to detect what is happening to the, you know, your final output. So for example, if you set your reference from your console and then you're measuring your in-ear monitors from a wireless pack, you're gonna see a lot of stuff that's happening to your signal that's not necessarily the in-ear monitors themselves. You'll see, low pass filter, high pass filter. You'll see different things that the pack is doing or the input of the transmitter is doing. To get a real idea of what the IEMs are sounding like coming out of the pack is by almost splitting it from the pack and getting that as a reference tone and then also measuring. So there's a lot of ways to use this to your advantage. It just depends on what your reference tone is and then what your final measurement information is. So this is the simplest way of doing it. Just straight pink noise from Smart, output directly back into the input, and then we can see a frequency response graph once we start measuring. All right, so let's show you what a measurement looks like. We've got Smart pulled up, everything's plugged in, tested, and we'll get the pink noise going. You kind of hear that. So again, remember the pink noise is being broadcast to the in-ear monitor from the little headphone amp that's inside this unit, but it's also going out of one of the outputs and being fed back in, and that is the reference. That is what we're measuring against. And so the measurement that you're gonna see is essentially comparing what's coming out of the IEM to what is being put in by that reference trace of pink noise. So we're gonna put it on here to get a quick look, and we can save it. Actually, we will set the delay, that's already set, and then save this trace. And so that is a measurement. We just measured the in-ears. The reason to measure in-ears isn't necessarily to have the most accurate measurement possible, because you really aren't going to get a very accurate measurement with these types of microphones, couplers, especially if you're not in the right environment, if you're not in a micro anechoic chamber, if you're not using the kind of standard measurement devices that we see in the industry. So this is more for comparing. So here's how you would do it. Let's say you're the monitor tech, monitor engineer, tech director. You get all the new in-ear monitors, and as soon as you open the box, you measure all of them. You save the traces. Like here, we've got this trace saved as IEM-1, let's say. You call that Tracy's in-ears. And then if you want to do it periodically, or if you only want to do it when a problem is presented to you, then you will measure Tracy's in-ear monitors and compare it to that golden trace. And then from there, you'll be able to see if the high mids are down or the lows are out, that sort of thing. So like, once again, it's not about the accuracy of the measurement as much as it is about the consistency of the measurement. So I'll give you an example. I believe we tested, which side did we test? Left, right? I don't remember. We'll compare one side to another, and you'll see some differences, of course. So, okay, so we tested the left one because the trace matches way too perfectly. So we'll test the right one here. There we go. You kind of see a little bit of inconsistencies. That's normal across any IEM manufacturers. 1 to 2 dB differences between left and right. There are certain things that would kind of concern me depending on if, like for example, here the whole spectrum is off by 1 dB. That might be a cable thing, that might be the in-ear thing. A little bit of high frequency difference here, that might concern me. But that also brings up a good point in that these systems are not accurate past 8K generally. And they're not really consistent from one measurement system to another. So to give you an example what that looks like, I've got another IEC 711 style coupler here. And this one is a little bit more complicated because it comes with a power supply, and it's sort of not as simple to use as this little guy with the little XLR directly into it. But it'll give you an idea of just what kind of inconsistencies we're talking about going from the same in-ear monitors, just one coupler to another. So we'll shut this one off, and we'll run this guy. I'll turn the power supply on. Left in-ear monitor. So we're matched here at about 1K to match sensitivity. This is that same left ear that we just tested. And you see the crazy difference past 8K or so between the two. And that's not to say that one is more accurate than the other. They just lose accuracy really past that point. So that just kind of gives you an idea of, again, it's not about the accuracy, it's about the consistency. This little unit would work great. This little unit will work great as well. It's just about creating a reference trace and then being able to measure up against it. So really quick, I wanted to touch base about why in-ear monitor measurements look this sort of way. You probably are used to seeing measurements of speakers, measurements of PA systems, where they're measuring it in an anechoic chamber, or it's a diffuse field measurement, and it's either a flat line or a sort of tilt from lows to highs. But generally speaking, it's relatively flat when most speaker systems are sort of aiming for that. And with in-ear monitors, it is slightly different, as you can tell. There is that same sort of tilt, but there are bumps here and there. Of course, it differs from manufacturer to manufacturer, but if you look at a database of IEM measurements, headphone measurements, you will see these sorts of patterns crop up here and there. So some of it is based on data and research from the 60s and 70s, like the acoustical impedance of the actual ear. So this data shows that there are resonant peaks of certain parts of the actual physical ear, like the concha or the bowl, this area right here, which is about 5 kilohertz. And then the resonant peak of your ear canal itself is around 2.7 K. And so these things have to sort of be compensated for in order for in-ear monitors to sound natural, because you're not getting those same resonances from, a speaker that's just playing at you. So we have to sort of compensate for those when we're developing the in-ear monitors. And you can kind of see that with this unit. There's a bit of a peak here, a little bit of a bump around 2K, and there's another bump at around 5K. And that does look weird on a measurement system, but you kind of get used to looking at IEM measurements and compensating in your mind for what is flat-ish and what isn't. There's also a lot of research from Harman that was done in the early 2010s about people's preferences when it comes to in-ear monitors and earphones and headphones. The Harman target, if you want to look that up on your kind of own research, is basically 64% of people prefer this type of sound, and this is their representation of what flat is, for example. And we make our products sound a certain way based on that research, based on older research, but primarily we have our own signature sound. We mainly use our ears when we're making products. We use all these tools, testing, all the research. We even have tools, predictive software that we're able to use while we're developing products that helps us get a long way. But at the end of the day, it's our ears, and it's the ears of the people who work here. It's our beta testers, it's our customers. So we use our ears. We're not, looking at a phase trace and trying to get a target phase response and then putting out a product. We're using our ears, and that's mainly how our products are made. So another thing that you'll find with different couplers and microphones is that they'll have their own resonant peaks. It's not showing it in these measurements because there's quite a bit of a drop off, but in some cases you'll see a resonant peak at like 8K. That isn't necessarily something that you can hear when you're using the IEMs, but it's a flaw or a feature, however you want to look at it, of the coupler. So that's another thing to take into account. And there are also major differences in how something will measure just from positioning. That's one of the reasons why we, for example, have these little guys made. And I'm not sure if the Audix folks include this, but it's a way for our, for our single bore canals to come on there with perfect positioning every single time. But just to kind of show you what positioning does for a measurement, we'll do this really quick. It's easier to show with the universal set because we can kind of maneuver them around here and there. So we'll put a little tip on here. So this is actually a good example of that resonant peak, this 8K thing that you're seeing. That's not in the in-ear monitors. It's just a product of the ear simulator itself. But watch what happens when I just slightly shift it. You see how the highs moved around, or push it down further. Positioning is a really important thing, especially for the high frequencies when it comes to consistency of measurement. So another thing to take into consideration when measuring in-ears. You could still measure our IEMs with the single bore opening by, using a bit of foam to go around the actual entry to the microphone, or a little bit of putty, just trying to get it to be as consistent as possible. And if you understand that it's not as consistent as you'd like it, just keeping that in mind when you're looking at the measurements. Another great use for something like this is to be able to test loudness, or test to see how loud your mix is or how loud your artist's mix is. You don't even need the transfer function measurement for this. You can just test directly off, if your artist brings you their pack at the end of the set, you see where the volume knob is, and you just play your recording from there, and you can measure kind of how loud the mix was at its peak. with something like this. You need to calibrate your microphone. So this is a calibrator by Brule & Care. It plays a 1 kilohertz tone at either 94 dB or 114 dB. And this is what will help you set the calibration for your microphone so you can actually measure how loud it is. So we'll play the tone, you kind of hear it there. We put it on here, we'll go and calibrate it to 94 dB, and you see it's being represented here as 94 dB. And then from there, you can measure how loud you're listening to something. So we'll patch this guy in. So play a little bit of music. And this is, I believe, A weighting. So this track is being played at around 94, 95 dB. You'll kind of see it jumping up and down. So that gives you an idea of how loud the mix is. And you'll have data to be able to back it up. If your artist is complaining of, ear fatigue or anything like that, this is a good way of showing, like, listen, there's plenty of research out there that shows what volume levels are healthy and what volume levels will actually degrade your hearing over time. That's not really up for debate. And this is an easy way of taking a look at how loud you're listening. You're also able to see how processing affects the sound of your IEMs, whether that's high boost on your pack or bus EQ, that sort of thing. You're able to see it happen in real time by measuring it. So we can show that as an easy example. We'll do the same sort of transfer function measurement. We've got this as the reference trace. We'll save that. And then we can introduce a bit of EQ. This will introduce a little bit of delay, so we'll compensate for it. And we'll raise, let's say 50 hertz. We'll add like 7 dB at 50 hertz. And you'll see that being represented by the reference trace that we took earlier and the current measurement. So fairly accurate. You see that it's doing what you're intending for it to do. One important thing to note when doing EQ or processing for in-ear monitors is that there's not really much to be afraid of because these are two isolated systems. So you can see that I just raised 1K by 8 dB. So it's raised here and it's not really affecting anything else. There's changes in the phase, but we're not hearing phase, we're hearing frequency response. So that is the most important metric when we're talking about the way something sounds, is the frequency response. You kind of have to divorce yourself from the way of thinking of processing like EQ filters when it comes to a speaker system or two multiple systems and sharing the same space. When you make changes like that, there can be artifacting, there can be negative effects to the frequency response when making changes in the time domain, mainly by adding EQ filters. When you have two systems that are fully isolated, you're not running into that same issue, that same effect. Really, the only thing you should be afraid of is extreme latency. If you're stacking processing plugins and you're getting to a point where your artist is going to be able to hear the difference between when they make a sound and when they hear the sound, then of course that's going to be detrimental. But there's not really that same issue, especially if you're just doing, listening to music playback with headphones or in-ear monitors. You can EQ all you want. But just as an example, the difference between not having this EQ plugged in on my little baby face processing and having it plugged in is the difference of 1/10 of a millisecond. So it's not really adding too much to the latency, nothing to be afraid of there. But it's an easy way to see in real time what your processing is doing to the sound. So again, all of this is for folks who are dealing with in-ear monitors all the time. It is a tool, it's a way to be able to test and diagnose issues. It's an easy way to talk to a manufacturer if you're having an issue, like, hey, I see a dip at 2K. Is there something that can be looked at here? As opposed to using subjective terms that might be easier. And it's really easier now than ever to have these purpose-built tools for in-ear monitors. I couldn't say the same thing even a few years ago because the barrier to entry to this sort of stuff would have been so high. But nowadays, it's easier than ever. It's more available than ever. You can have as many tools as possible to make your in-ear monitor mixing as effective as possible. Things like this, things like maintenance tools, the vacuums and things that we make. So hope this helped. I hope this was a bit of an insight. Again, don't tear me apart in the comments if you're a measurement nerd. Trying to not delve into that too deep. There's a lot of research, there's a lot of resources. I'd recommend checking out our friends at the Headphone Show on YouTube, Critical, there's a few others. You can even look up the AES papers if you're really interested about some of the acoustical research that goes into all of this. Try to link to whatever we can in the description. But yeah, hope that helped. Thanks for tuning in.